Hey, Math 20-1s, we're going to solve some trig equations today. All right. Note, a restriction on a trig equation limits the values of the solution set, as the solutions must fall within the limits posed by the restriction. Very important to remember that. So, first example, solve for theta to the nearest degree, and our restriction says theta must be greater than or equal to 0, less than or equal to 90 degrees. That means it's a quadrant 1 solution. So back in grade 10, if you're asked to find the sine of angle theta equals 0.35, you'd use your calculator, you go second function sine of 0.35. You come up with the appropriate angle. Theta would equal 20 degrees to the nearest degree. If I look at something like 10 tangent theta minus 32 equals 0, I want to solve this equation for tangent theta. So I'm going to add 32 to both sides, move 32 over here, and then I'm going to divide by 10. So a pretty simple equation. Tangent theta would equal 32 over 10. How do I solve that? Second function tangent, 32 divided by 10. We get an angle of 73 degrees. Now, if you're not getting these angle measures, make sure you change your calculator's mode into degree mode. If it's in radian measure, it will not work. Third example, 9 cosine theta minus 1 equals 0. Again, I want to solve for cosine theta, so I'm going to add 1 and divide by 9. So cosine theta would equal 1/9. Again, in grade 10, we solved this by going second function cosine, 1 divided by 9. And angle theta is 84 degrees. Now all these angles, 20, 73, and 84, are angles between 0 and 90, so they fit our restriction. All right. Ooh. So if you're now asked to solve theta to the nearest degree, but look at the restriction. It has now changed from greater than or equal to 0 to less than or equal to 360. So now we have to look in all 4 quadrants, not just quadrant 1 angles. So we learned the cast rule. We now have to take that into account and look into all 4 quadrants. So if you're asked to find the sine of theta equals 0.35, last slide we said angle theta was 20 degrees. That is no longer the case. Now we're going to go second function sine of 0.35. We're still going to get 20 degrees, but we're going to call that the reference angle. So we say the reference angle is 20 degrees. We should note that the sine ratio is positive in quadrants 1 and 2. So a reference angle of 20 degrees in quadrant 1 is 20, and in quadrant 2, what is that angle? So if I draw a 20 degree reference angle in quadrant 1, well, in center position is still 20 degrees. If I draw a 20 degree angle in quadrant 2, well, the angle in center position is now 160 degrees. Those are the 2 solutions for this equation. Theta could now equal 20 degrees in quadrant 1 or 160 degrees in quadrant 2. Wow. If you plug in 20 or 160 for theta and you go sine of 20 or sine of 160, it'll give us approximately 0.35. All right, let's try another one. 10 tangent theta equals or minus 32 equals 0. We solved this one last slide. The only change is the restriction. So tangent theta is 32 over 10. I go second function tangent of 32 tenths. But that angle now I'm going to call my reference angle. So instead of theta equaling 73 degrees, the reference angle equals 73 degrees. We then ask ourselves, this tangent ratio is positive. So where is the tangent ratio positive in our cast rule? Well, tangent's positive in quadrants 1 and 3. So I draw my coordinate plane. I draw a reference angle of 73 degrees in quadrant 1, and I draw a reference angle of 73 degrees in quadrant 3. So theta has solutions then of, in quadrant 1, the angle in center position is still 73 degrees. And in quadrant 3, it's going to be 180 plus 73, which makes it 253 degrees. So the solutions for theta now are 73 and 253. So the restriction allows us to go past just quadrant 1. I have to look into quadrant 3, which also has a positive tangent ratio. All right. If we try a third example like C, cosine theta is negative decimal 267. Well, the first thing I should note here is the ratio is negative. We're still going to use the positive value to find the reference angle. So I'm going to go second function cosine. I'm going to forget about the negative sign and just type in 0.267. So second function cosine of 0.267 gives me a reference angle of 75 degrees. If I go back and look at the original equation, the cosine ratio here is negative. So I ask myself, where is cosine negative according to my cast rule? Which quadrants? Well, according to the cast rule, cosine is negative in quadrants 2 and 3. So I'm going to draw a 75-degree reference angle in quadrant 2. There it is. That means in standard position, the angle is going to be 180 minus 75, or 105 degrees. And if I draw a 75-degree reference angle in quadrant 3, there it is. This angle in standard position is going to be 180 plus 75, so a 225-degree angle. Therefore, those are the solutions. Those are the solutions to this equation for cosine theta. 105 degrees, 225 degrees. Part D. Again, the same restrictions. Let's solve for sine theta. Get sine theta by itself. I'm going to minus 3. I'm going to divide by 4. So sine theta equals negative 3/4. As the note on part C said, I'm not going to use the negative sign when I find the reference angle. I'm just going to go second function sine of positive 3/4. That'll give me my reference angle of 49 degrees. Now I ask myself, where is the sine ratio negative? Because it's negative up here in the ratio. So I say, using the cast rule, I believe the sine ratio is negative in quadrants 3 and 4. So I want to draw my reference angle of 49 degrees in quadrant 3. My angle in standard position would be 180 plus 49, or 229. If I draw a reference angle of 49 degrees in quadrant 4, well, my actual angle in standard position would be 360, take away 49, so 311. Those are the solutions to this equation. Theta would equal 229 or 311. Yes, we're amazing. Excellent. So the first part of the assignment I want you to look at deals with stuff from the last set of notes, as well as solving some simple trig equations. So I'd like you to try those. And if you're up for it, even if you're not, I believe I'm going to give you some tougher questions. So here are the notes for even more difficult trig equations. All right, let's try E. E says I now have two tangent thetas. In order to solve any equation, you want to get your variables together on one side. So I'm going to minus tangent theta from this side. And at the same time, I'm going to subtract 3 from both sides. So 3 tangents minus 1 tangent gives me 2 tangents. And negative 2 subtract 3 gives me negative 5. I'm now going to divide both sides by 2, so I get tangent theta equals negative 5/2. This is part E of the last question, so the restrictions are still going to be between 0 and 360. So I have to look at all 4 quadrants. I'm going to find the reference angle, so I'm going to ignore the negative sign when I find the reference angle. I'm going to go second function tangent of 5 divided by 2. My reference angle becomes 68 degrees. I then ask myself, where is the tangent ratio negative? Well, tangent is negative in quadrants 2 and 4. So I'm going to draw my reference angles in quadrants 2 and 4. So a 68-degree reference angle in quadrant 2 and a 68-degree reference angle in quadrant 4. What are the solutions then? Well, I would say a 68-degree reference angle in quadrant 2 is going to be 180 less 68. So that angle is going to be 112. And in quadrant 4, it's going to be 360 less 68. So in standard position, that angle is going to be 292. So theta is 112 degrees and 292 degrees. Those are the solutions that satisfy the equation at the start of the question. Let's look at a little more difficult one, something like F. 7 sine squared theta minus 3 equals 0. Well, again, I want to solve for sine theta, so I can find my reference angle. So I'm going to add 3 to both sides, and I'm going to divide by 7. Add 3, divide by 7. I get sine squared theta equals 3/7. Well, we know how to get rid of an exponent 2. We take the square root of both sides. So I'm going to take the square root of both sides of this equation. And remember, anytime you take the square root of an equation, you must include the positive and negative. So sine theta equals plus or minus the square root of 3/7. From here, I want to find the reference angle. Again, I'm going to ignore the signs. I'm going to use the positive ratio. I'm going to go second function sine of the square root of 3/7. If you do that properly, you're going to get an angle of 41 degrees. So the reference angle is 41 degrees. You now ask yourself, where is the sine ratio positive or negative? Well, with restrictions between 0 and 360, the sine ratio is positive in quadrants 1 and 2. It's negative in quadrants 3 and 4. So I want to check all 4 quadrants. It's positive in 2 of them and negative in 2 of them. So if I draw my reference angles of 41 degrees in each quadrant, there they are. In quadrant 1, in standard position with a 41 degree reference angle, theta is 41. In quadrant 2, in standard position, it's going to be 180 minus 41, or 139. In quadrant 3, it's going to be 180 plus 41, 221. And in quadrant 4, it's going to be 360 take away 41, or 319. So there are 4 solutions to this equation. There they are. If I look at one more real tough one, tangent squared theta minus 5 tangent theta equals 14. Well, this is a lot like a quadratic equation. It's degree 2. Looks like there's 3 terms, so if I set it equal to 0, it looks like this. Well, that looks a lot like a trinomial that I might be able to factor. So I'm going to factor the left side of this equation. What 2 numbers add to negative 5 multiplied to negative 14? Hey, this is really a simple trinomial because there's a 1 in front of my squared term. So 2 numbers that add to negative 5 multiplied to negative 14 are negative 7, positive 2. Factors then should be tangent theta minus 7 and tangent theta plus 2 equals 0. If I expand out these 2 binomials, I get the trinomial up above. It just happens to be in terms of tangent thetas instead of x's or y's. I'm now going to solve this equation like I would any quadratic equation by factoring. I'm going to let each factor equal 0. So tangent of theta minus 7 can equal 0, or the tangent of theta plus 2 could equal 0. Well, now we're back to what we've been doing. Now I can solve these trig equations. To solve tangent theta minus 7 equals 0, I'm going to add 7 to both sides. To solve tangent theta plus 2 equals 0, I'm going to minus 2 from both sides. Our next step would be to find the reference angles. So the reference angle of tangent theta equals 7. I'm going to go second function tangent of 7. I get a reference angle of 82 degrees. Tangent theta equals negative 2. Again, the ratio is negative, but to find my reference angle, I ignore the negative sign. So I'm going to say second function tangent of positive 2 and get a reference angle of 63 degrees. And from here, I ask myself, where is the tangent ratio positive? This ratio is positive, so tangent's positive in quadrants 1 and 3. Over here, I ask myself, where is the tangent ratio negative? Well, over here, the tangent ratio is negative in quadrants 2 and 4. Now I want to draw these angles in standard position. So an 82 degree reference angle in standard position in quadrant 1 will give me 82 degrees. And an 82 degree reference angle in quadrant 3 has an angle in standard position of 262 degrees. Look at the other equation. A 63 degree reference angle in quadrant 2 would give me an angle in standard position of 180 minus 63, or 117. And in quadrant 4, a reference angle of 63 degrees would be 360 take away 63, or 297. So there are solutions for this equation. 82 and 262 from the first part, and 117 and 297 from the second part of the equation. You guys are amazing. I will have a worksheet for you on some more difficult trig equations to solve. They're going to be fun. We'll see you guys soon.